Hello, Andrew. Hello, hello. Let's see. Now you can check how many C lines of code there are. Comments won't be calculated properly working on it, but estimates should be valid. Nice. Thank you, Andrew. I'll take a look. I think I will probably use Forest. Um, I don't know, over time. So I think it will become like a nice tool to have in your toolkit just to, take a look around, get some information about a project, or like just get some information about your own projects. Let's see on YouTube. Thanks for the consistent streams. Thank you. Really inspiring and helping me in my journey in learning Z. Nice. Okay, I need to make myself some tea. No, wait, isn't it this? Yeah. So board KFK, 10 minutes, and then we start. I'll be right back. Hello, everybody. He is coming. For Zini, it shows like 20 million lines of C. Yeah, like three-seater moment, I guess. uh, okay, so the plan for today is as follows. Um, Basically, I was trying to make fuzzing work, native Zig fuzzing work on macOS, but it's not just macOS. It's macOS and also um, ARM 64, Arch 64. Sorry. So the combination of these two things is like throwing off the Zig fuzzer a bunch. And I was investigating this a little bit on my own. Then I investigated this also a bit with Andrew, and he gave me some pointers. So I guess the idea is to basically continue that investigation today on stream. We'll see how it goes because yesterday things seemed to make sense, but obviously when you're on your own, it's different. And yeah, in the meantime, I was also helping out with there's a donor bounty for making Go tests work with Zig. Like there's a linker flag that Go occasionally uses. It was causing trouble, and I was helping diagnosing that. So I need to update some information on the relative issue, and then I'm gonna switch back to the fuzzing stuff. So that's basically the plan for today. I know that I have a PR for Zine that I need to merge. Actually, a couple probably. But I think I want to dedicate the entire stream to this fuzzing stuff, or at least make, enough progress until I get completely stuck. Maybe something along those lines. So we'll see. Okay, let me go get my tea. Should be ready now, and then I will start. Enjoy the Go build error stuff in the meantime. Hello, proper bag. Also, as a side note, so after all the streams we toggle, I was able to apply for Twitch partner. That doesn't really change things a lot. But there are some minor perks in being a partner. For example, I will be able to create a team on Twitch if the application gets accepted. I can create a team, and so I can create like Ziguanas, I guess, and so that people can stream in that team. Again, not a huge thing. Hi, Silverbug. Not a huge thing, but something. Okay, sorry guys, I was replying some to some messages. Programming Go today? And no, I'm done with Go. Is there any Z community which normal people can join? Um, that's a loaded question. Um, normal people can join. So yeah, so if you go on the official website and you click join a community, that sends you to a wiki page where there's a bunch of communities listed. Now, how normal are these people? I don't know. I guess it depends on what your definition of normal is. But like the Zig programming language Discord, that this is, I guess, as normal as you can get when it comes to community. I run the software you can love Discord server, which is listed, I think, down below. I think it's here. It's still listed under Zig Showtime. But in any case, so this is my Discord server, but which everybody is welcome to join. But it's not a Discord server designed to support people that are learning the language. So, like, if you have questions like how do I do these, or I'm new, I'm getting stuck, how do I block myself? Then I would recommend either the other Discord server, the one listed here at the top, or as New York Side is saying, try the forum. Ziggy.dev is pretty cool. So yeah, again, depends on your definition of normal. Okay, let's get started. Sorry, I was still catching up with messages. I programmed an algorithm that works for small small numbers, but not for large numbers. I want to ask them in the community. Yeah, I would say Zigit or Discord. That is what you should be aiming for. Those are going to be the best places to ask these kind of questions. Okay. Or alternatively, I can also help you on stream. So if you have a short snippet, so if your program is not too complicated and you can post it on zigbean.io, well, it doesn't have to be on zigbean.io necessarily, but if you don't paste it like in chat, because I won't be able to understand it if it's in chat, but you post it somewhere where I have like indentation and syntax highlighting and it's not too complicated, I can take a look and maybe give you some quick feedback. Okay, so let's go reply to the Go stuff. There's a bounty on adding -x for macOS. Yes, this is the bounty. And so the problem with these things is that while you can phrase it, while some of it is phrased as let's add just support for the -x flag, things tend to be a little bit more muddy when you get down to it. So more specifically, what's happening here is that yes, this test suite doesn't run because of the -x flag not being supported. But then on the other hand, if you do enable it, so what we learn is that if you enable it, first of all, there are some other questions on our end about how the linker should work internally. But let's set that aside for a moment. Although that is also another source of like and not confusion, but like it complicates. It's not just add support for this flag. It's like it's something more that you have to think about. But then the other problem is that like this list of steps does not work for running tests. At least does not work for me. Maybe it worked for Jacob, or maybe it worked with Go at a point in time. Maybe with Go version, whatever version was available in October 2024, maybe this was a correct list of steps, but this doesn't work anymore. If you do this now, you will get a complaint from Go that tells you, it yells at you because you're trying to access a module under internal, and internal stuff you can't import from outside. So you have, at least in my case, I had to build also Go in this repository because the system-wide one was giving me this trouble. Maybe in the case of Jacob, this Go is sim-linked to a Go that he built from this repo. So he was maybe doing the same, just he forgot that he had like this sim-link setup, and he didn't know that if you don't have this symlink set up, then it's not going to work. And then there's another problem where like this actually this invocation has a problem that it pulls in a test that should be disabled because something is not set up as it should. Why am I opening this? Okay, so we got so with this thing we got go build, and then you go up. Is this it? And then you zig2cc bean go. Yeah, and then you test. Hey, real LRK, thank you for the raid. Hello, everybody. Hello, hello. We are doing Zig work, but doing Zig work doesn't mean that we only work with Zig. It means that we also work with other languages because Zig is a compiler toolchain. So everything that might want to use the toolchain. Hello, Crispies. Sorry, Crispies. So everything that might want to invoke and leverage a compiler toolchain is part of our use cases. So this is why you see me touch Go. I'm touching Go. It wasn't my plan in the beginning. Honestly, it's not like it's something that I like doing, but I am touching Go. So now I'm curious, can I do dash internal? True. How do you specify custom flags? I think there must be a way of specifying custom flags for Go build. Go build custom flag. Oh, this is back when it was plus build. This is really old. Let's see. Go command arguments. Dash tags. Okay, so it's dash tags and then tag list. Let's see. Like Togglebit, you take a trip around each language you can call from Zig. No, I'm not exactly doing I'm not doing like a review of other languages. I'm specifically here trying to make progress on an issue. And the issue is basically using Zig as the C compiler for Go. And it works, but there we go. That's how you run this correctly. Freak. Okay, so I finally solved this. So I'm trying basically to make progress on this. Yeah. Okay, so this is what I wanted to do basically. I really just wanted to add this comment here. And I'm going to tell the people who's working on this about the more precise steps. Maybe they don't really care about actually this stuff because they're testing on Linux. Okay. Actually, it's tags, not tag. Let's edit tags. Okay. So comment made. Let's forget about Go for a while. I am sorry, Go. Go away. What's the problem? Exit. Okay. Then this is synthetic stuff. So I guess we can save and close. Oh, this is modified by an external process, of course. Git status. Yeah, we have some changes in there that we didn't commit. So I'm gonna discard them, I guess. Okay, I'm gonna switch now to the fuzzer branch, and now I'm gonna start messing with fuzzing. So I'm gonna give a short explanation of what I'm trying to achieve, what the problem is currently. Just let me switch first. Okay. Let me see. Can I close some other things in here? I think I can close everything Go related because I'm not gonna use it anymore. Test standalone. Official Zig website can go. Fuzz new, not needed. Personal website. Another Zig source. Oh, yeah. Close this. What else do we have in here? Close this. I have a bunch of stuff open, huh? Okay, I think we're in a better position. I see they use Ghosty instead of the native terminal. Are there pluses for you using Ghosty? The native terminal, if you mean this guy here, this guy is awful. The macOS terminal is the worst. It doesn't support basic escape sequences. It's slow, and it's really bad. I would recommend to not use this guy. This is like horrible. You can use iTerm. iTerm is very featureful, but it's kind of heavy and not super fast. In my case specifically, iTerm doesn't do well with inline images. You see how well these are emojis actually, so this is fine. But like I support Twitch emotes in the terminal. Like let me show you some. I'll show you some of mine, some standard ones. I'll also show you some toggle bit. So I support these emotes, and these are basically these are images that are being displayed and rendered in the terminal. And if you try to do this with iTerm, it starts lagging like real bad. Not you don't need a ton. Like I think maybe I would need like twice this amount. Maybe we need like 10, 11 emotes, but then it starts lagging hard, and it shouldn't be like that. So yeah, no, there are some real pluses to using Ghosty. I think if you're using already something good like Kitty, Alacrity, Foot, and you're like where you are, you probably don't need to switch. I don't know, maybe you should try it, but then chances are that you're fine where you were already. Yeah, but if you're using something else, ugh. Foot runs on macOS? No idea. Okay, so here's the situation. Here's what I'm trying to achieve. here I have a hello world application, basically. And my hello world application is, ignore the banana stuff, but my hello world application has a main file that this is like auto-generated by calling zig init. Sorry, not dot, just zig init. And it auto-generates some stuff. So let's ignore these banana tests, put them away. But here's the interesting part. The interesting part is we have a fuzz test. So this is a normal Zig test, but internally it calls std testing.fuzz, and it fuzzes a function that you pass to it. And this function is, well, it gets called multiple times. So like this one is going to get called multiple times, like a ton of times, every time with different input. And the fuzzer uses code instrumentation to know when it's exploring, when it's making progress in the program. And the idea is that this is like a very hello world example of fuzzing that basically needs to find a password. Like, can you find me? And it basically, this is by the way, fuzzing tries to find crashes. So your function, this hello world, like this simple example fuzzing function, crashes only when it's given can you find me as input. And so the fuzzer basically needs to figure out that this is interesting space to explore and find the password, basically find can you find me. And if you pass, and so you can do zig build test -- fuzz, and if you pass -- fuzz, then you will enable fuzz testing, this thing. Now, this does not work on macOS currently. I don't know why on macOS I don't inherit the other directory. What does it fuzz? All strings? Not all strings. It fuzzes random inputs, but they're not completely random. They are random to some degree, but there's also knowledge about, for example, the fuzzer can know how many, how far along the comparison succeeds. Like when you're comparing strings in a non-optimized way, you're comparing byte by byte, and the fuzzer can know how much progress you're making. It knows that you failed the comparison at this letter, at this one, at this one, at this one, and so it can basically figure out the password, by basically figuring out a prefix and then making progress byte by byte. That's one way it can do it. It can also observe. It can observe basically comparisons, like you do something greater than something else. It can see that you did that, and so that can be used by the fuzzing algorithm to then, in future iterations, try to get on the other side, like try to flip the result of a given comparison. That kind of stuff. I'm being very high level in the description, but the point is that the fuzzer has code coverage knowledge. The fuzzer knows which paths it's hitting, which is interesting. Can you control how many different fuzzes are tried to limit the time taken? I believe currently you cannot, but it is planned to do so. Like the idea is that the basic way of using fuzzing is that you just always keep it on. So you have like you have it's not part of your main testing process, but it's a separate dedicated like testing system where you kind of keep it on for like, I don't know, 2 days straight, and then it keeps finding as many crashes as it can in a time period. That said, it does make sense to do a little bit of fuzzing from time to time and like time box it basically. So this is not implemented yet, but it is planned to implement it. Yes. But I can tell you that historically, like if you look at other fuzzing tool chains, like I think the most famous one is AFL++. If you look at the AFL++, it's not really something that you run for a little bit. I mean, obviously you run it for a while and eventually you are going to shut it down, but it's generally like a thing that you keep open, and then when you want to stop it, like you Control-C it, long story short. So this is just to tell you what usually people do when they approach fuzzing, but then obviously things can be done in whichever way you want. And in this case, Zig is supposed to have this use case as part of I guess the feature set that you get directly from Zig. So in any case, you saw that I tried to run this and I get a linker error. Now I have a branch with some changes made to it. These are some of them. There's more. If I do git log -p, you can see that there's also other changes that I made. I disabled some features. There's a web server that should show you code coverage in a web page and show you like in real time what the fuzzer is exploring. But this one doesn't work on macOS because we don't have in the standard library code to parse dwarf info out of macho files. So on Linux this works, on macOS it does not work, and I just commented it out because I don't know how to write a macho dwarf parser, or like it's not something that I'm prioritizing because there's other problems. they're like we're not even getting to a point where, oh man, it would be nice if we could enable this. We're failing earlier than that. So my goal right now is to understand what's going on with the linker, why we're failing, and make it work. So let me Zig build. You know what? Maybe I'm gonna do it like this. There we go. Okay, I'm gonna Zig build a version of Zig that has my patches in it. I need to build it because previously I was in the other branch. I was doing the Go stuff. So now I switched away from the Go stuff. Now I'm switching back into the fuzzing macOS branch, and so I need to enable this stuff. As someone that tried Zig a couple of years, boy am I old, ago, is async back again? Not yet. It might come. So far, it seems that there's like promising things are happening for async to come back, but it's not back yet, and it's not being prioritized much. But it is not off the table, and there's like a general, I would say there's a general positive sentiment towards async. But the point, I guess, here's the main takeaway for you, Mogambro. The idea is the previous implementation of async was very POC, and in internal mechanics. It's not in terms of like the semantics of the keywords. Those were fine, but how it was implemented internally, there were like a lot of like inefficiencies. For example, like in the way that LLVM would like in the end generate the machine code when async stuff was involved. Now, the problem, the reason why it didn't come back right away, well, setting aside the specifics of moving to self-hosted, but the problem more in general is that now that everything in the compiler is of better quality, the old quality of implementation of async, it's a little bit too bad compared to where everything else is at this point. So long story short, if async comes back, it needs to be an implementation of a quality that is comparable with the rest of the compiler toolchain. And so those code generation problems would need to be fixed. So long story short, this is basically the new blockers that came into being in the meantime. That's kind of the idea. Okay, so we built Zig2, and now if I do Zig2 build test fuzz, now it's not going to fail like this, but it's still going to fail. That part I get, but I can never get the use case or metaprogramming for that matter. Still learning Zig. I never understand comp time. Can you help? Yeah, that is an extremely generic question. I think you would need to give me a more concrete a more specific example that you have trouble understanding that I could explain. So explaining, like making you understand all of comp time by voice on stream, it's kind of hard. I don't have, I don't know exactly what that would entail. But if you bring a specific thing, then maybe I can help. By the way, did anybody? So here I linked the Zigbean. Did we get any Zigbean link? No, we did not, right? So, okay. Okay, so look at this. It built, and now it's fuzzing. But I can tell you that this is not behaving correctly. Because fuzzing should actually find that crash in the blink of an eye. It shouldn't take this long. Another reason why I know that this is not running correctly is because I'm gonna do verbose everything. And then if we look at this executable, which is what I was doing here. Well, okay, this is not my exact executable that I built now, but it's from a previous run. If you print the sections, I can tell you that the stuff relative to fuzzing is the SunCov stuff. And the SunCov stuff is in a bit of a weird situation because we have SunCov counters, SunCov PCS1, and then we have, look at this, we have SunCov counters and SunCov PCS1 with a single dash of size 0. And then, so here's the two problems that I know we need to understand, we need to somehow fix. One is, this is clearly a mistake in the linker code because we're generating, somewhere we're forgetting about a underscore. And so we're generating these things wrongly. Problem number one. Problem number two, and the thing is, this one is correct and this one is wrong. I know that this one is correct for two reasons. And maybe we could like investigate a little bit more to see if it is correct. But one reason why I know this is correct, it's because these two sections work like this. One is called counters, and the other one is, I guess, program counters. So it works like this. The compiler, so not LVM, this is something that Zig decides. Basically, Zig decides where are in the source code points of interest. So when a comparison is interesting, when a branch is interesting, where like an if or when a for loop is interesting, and there's a built-in, and by default, all these things are always interesting. But there's a built-in, for example, to disable them. So you can use @disable instrumentation in a scope to disable instrumentation of a scope. So none of the for loops or the ifs or the comparisons in there will be considered interesting by the compiler. The ones that are considered interesting will end up mentioned in here. So PCS1 is literally a list of program counters, and a program of program counters, so that it's like virtual memory addresses that then you can go look up in the compiled executable, and you will see that it will correspond to a specific line of source code where a comparison is happening, or like an if statement is, that kind of stuff. Counters is a section where everything is an array of individual bytes. And so what happens is that while your program is running, every time you hit one of these program counters, the byte that is at the same index, but in this other section, in this other array, think of them as two arrays. So the byte corresponding to a program counter in here, so when you hit a program counter that's listed in here, and this program counter is at index A, then inside counters at index A, there's going to be a corresponding byte that gets incremented by 1. So counters is a list of, well, counters as the name says, but it's like a list of buckets where every bucket corresponds to a program counter in here. So this is an array of addresses. So of U64s. This is an array of bytes, and I looked at the respective sizes, for example, and I could see that this guy is 8 times this guy. I can't see these just by staring at at the hexadecimal sizes, but I run these numbers through Python, and I could see that the one divided by the other gives me 8.0, and yes, that's the like the, I don't know what to call it, like the relative size, right? This is bytes, and this is like 8 bytes. Like yeah, for each entry in here, you have 8 bytes here, which is absolutely correct. Now, another thing that I could do is open PCS1, and in PCS1, I could like pluck one and then use what is it? I can use address to line to then turn that into a line in Zig source code and see and confirm this information. I didn't do it from in this executable, but I was doing it in object files when testing this stuff out with Andrew. So in general, I would say that for now, my assumption is that these sections are generated correctly. This is all fine. The problem is that this is crap. And then there's a second problem. So the information in these sections is referenced by the fuzzer like this. We grab this information like this. And I think that we're doing something wrong somewhere in this stuff. Oh, maybe it's this. Okay, so this is probably already a problem. Although this is not going to solve it because these queries for these guys, it doesn't really generate them. But in any case, so here's what happened. What happened is also that we logged the pointer that should point at where these guys are. And the number that we got was outside of the boundaries of the executable. So it was completely bogus. So out of curiosity, I changed that. Let me now rebuild everything and see how that goes. I'm going to leave on the verbose stuff. It doesn't really hurt while debugging. It says error, but it's just like it's not really an error. This is Zig being a little bit too dramatic. Okay, so it goes back to fuzzing, and then it gets stuck there. Okay, so now I'm curious. I'm curious to see this bad boy. Yeah, object dump, and then I want sections. Section headers, right? Nice. Okay, so now we should be hooking up to the correct ones. That is actually, I did solve one problem. But then it's still not working though, because we were seeing here that it was just like this should find a crash right away if it's working correctly. It's not reporting a linker error. So it's me. I'm asking verbose link. So I'm asking Zig to give me the exact invocations to the linker because I want to have access to the intermediate artifacts. Like let me show you this thing. If I do rmrf Zig hash, and now I need also to rebuild everything from scratch, you will see that I'm building, and you will see, for example, by passing verbose link and verbose. Actually, this verbose is probably redundant. Verbose link is the one that I care about the most. But for example, I will be able to see that. What is it? The more interesting stuff. Lib compiler RT, that is fine. For example, I can see libfuzzer. I can see the fuzzer being compiled. I can see the object file of my tests before it getting linked into the final executable. So when I was debugging stuff, for example, I was trying to, I don't know yet where things go wrong. So it was a good idea to be able to access the intermediate artifacts and not just observe the final executable, because if you can see that something is wrong here already, then you know that it's wrong in the process that generates object files, and it's not in the final linking step that something went wrong. So if I take out all these things and I just do -faz, then you will see that it doesn't spam anything. Okay, so what do we want to do next? Here's what we want to do next. I want to build everything like this, but I want to remove logging. I want to run it again, stop it, and then here I'm gonna cat not this, but I'm gonna cat temp libfuzzer log. Okay, so we're still getting this. We're still getting the fact that program counters is PCS is basically a variable that should point at this section here. Well, this is the old tab. I fixed this in the meantime. So this is the old. This I had like this weird soup. Now this is fixed. So I guess I'll pull it up anyway. But in any case, let me copy this. Let me copy this number. Let me copy this number, and then let's run LVM object dump. Right, the old one doesn't exist anymore because I cleaned cache. So let's go here. Let's find the new test executable. Copy, paste, pipe less. Before I go, copy the address. Go in here, search, and check this out. The address where the sections are, boy, is it low. It's really low compared to what this value says it should be. So this address is really sus. Like this is a 1004, right? Sorry, 104, right? These are all addresses at 1000. Like, man, there's a lot of difference between here and here. So why am I getting this disparity? I don't know. Is it because of... Actually, I don't know because of what. It seems a problem, right? So I think that the linker is doing bad math in generating these things. More specifically, what would be the correct value? This would be the correct value. The correct value would be this guy. I guess you should subtract the address you get from running program to its own base address to obtain its offset from the start of the binary. You think that's it? You think that the problem is that there's an offset that we don't see here? I don't think that this is how this works. The reason why I don't think this is how it works is because is the address of PC always the same? Well, we can test this. We can run it multiple times and see if it's always the same. But the reason why I think that the offset is already baked, the offset at which the program is loaded, it's already baked in here. It's because we are able to take program counter values. I've taken the values inside program counters. So maybe you weren't here when I was explaining this, but PCS1 contains a list of program counters, like of addresses in virtual memory. And I can run other... Oh, but wait, no, it's not just this one. We can do that with runtime values. So you know what? Maybe this is what you describe. I'm not sure. Actually, my reasoning might not apply to this. Address layout randomization. I don't think this is really happening much. So let's see. I'm gonna delete the log stuff. I'm gonna rerun the fuzzer. I'm gonna cut logs, and this is the address. Wait a second. This is a good address. Was I running bad stuff? Is this a good address? Am I going insane? This seems a good address. Uh-oh. Maybe you're right. Maybe this is what's happening. Let me run it again then. All right, we don't need less. Yeah, the address changes. So you're right. How do I know? How do I know the offset at which the program is running in order to know what the actual value that we're getting here, if this value is right or wrong? There is definitely something wrong with this. I can tell you that there is something wrong 100%, because let me show you the printing code. But the wrong stuff is this. PCS is PCS start 0 to PCS end minus PCS start. PCS start is the section start symbol and then the section end symbol. Like, these are like weird symbols that get generated by the linker, and then so we subtract them, and this should give us the length. And here's the problem: this process gives us the PCS is at a given address and has a given length, and the given length that we see here is 0. So this is 100% wrong. You can get a pointer to your own header with mh execute header or something like that. I don't remember. We have these bad boys. We have text, which is already at a weird address. I don't know. Do this guy get loaded? No, but this is still, there's still gonna be some padding, right? Before it, maybe. Yeah, I don't know what's the. Although wait, this is you're talking about symbols, not section names. So wait a second. Let's do this. So we have execute header. Yeah. Underscore mh execute header. Yeah, no, I was trying to see what the actual symbol name is. Okay, mh execute header. Okay. Yeah, I think this is a good thing to do. Let's try to do that. Let's see, how do we do this? Is it? I think it's minus base, but plus 1,000 or like a million, whatever the number was. But I guess it doesn't matter, because what we expect is the other numbers to make sense at that point. Okay, let's see what we get now. Cannot form a non-pointer type usize. Oh, right, because this gives us a number. How do we do hex though? Is X gonna give me hexadecimal representation? Hopefully. I think you are right. Oh snap! What? Okay, so I do it with a single underscore. Let me think. There's definitely some nuance related to that when you're using the extern. When you're using extern, I don't think so. Let's see how it goes. Does not seem right. Yeah, I agree. It does not seem right. So I think what's happening is that it's keep in mind this is buggy. We know that this is buggy. I think that it's just that these PCS stuff, those I think these are called synthetic symbols, and I think that those synthetic symbols are just being generated uh, with wrong values in it, which could make sense. Shouldn't the order of these things be respected? In any case, it gives me the problem is this. In any case, it's not just that the start address is that. It's also that we have a length. We have start and we have end. And end is or stop, whatever you want to call it. The problem is that end is actually also set to the same value, and it gives us length 0. And we know for a fact that this section is not of size 0. So that's the start of a segment. The segment being what? Underscore data. That is the segment, right? Maybe, maybe not. Although there's a ton of stuff in data. Also, I know that this guy should go inside. These guys should be data cons, not data. That's on me. I think it's like this. And this is also like this. And then no. Simulcasting counters goes in data, and Simulcasting PCS goes in data const. We'll need to rebuild the compiler though after this change. Also, why am I opening another editor? I don't know. Okay, let's see what happens after this. You display your segments. Yes. So the segment, I mean, although you did so in the source code, right? That I was putting this stuff under underscore data. And now I changed it to put PCS under data const and leave counters under data. I think the problem is that though they both suffer from the same problem. Here we go. Simulcasting counters. I think that these values are just not being set correctly. I don't know what mechanism in the linker is supposed to set them, but it's just not doing a good job. I also know that I want to do this. The data const change. I think it makes sense. Is there a way to disable that shit? You know who knows? Claude. There's no way that Claude doesn't know. Let me help with the safe and legitimate use case. Bro, I just want to debug my shit. Oh, there we go. Or when launching a process that you want to debug. No pie. Let's see. No pie. I hate pie. I guess we don't want pie. I'm sorry, proper bug. Have a nice day, real LRK. I'm sorry, proper bug. Somebody has to do this stuff, I guess. I want to learn also how to do it. Like I'm a bit of a noob when it comes to these things, so this is like good practice for me. Okay, we were saying we could run this, so we could do this thing, and then we could do. Although I don't know if this is gonna work also with the sub processing. Would you like me to explain more about? No, bro. I just want to debug my shit without going crazy. Let's see the reply. Here's the quick version, and I don't want the quick version then. What was it? We might need this though. Which I think I can do this because I disabled some security features. Hopefully this allows me to do it. But let's see if the easy one works first. I don't think it worked. Definitely did not work. It probably worked up to a certain point, but it didn't work with this invocation. I could hack the build system to invoke this with that environment variable set. I'm not sure if that would have the desired thing though. Let's see if this command works. Please. Did we win? That number seems nice. I don't remember if it's the one on disk. Number keeps changing. Well, okay, so this does nothing. Might as well. You know what? Also, why am I trusting an AI? What is this? macOS what? Sonoma. Okay, well, let's see. macOS. I don't have an answer for you. Awesome. ASMR. Usually use a wrapper programmer that does POSIX spawn itself and sets the attributes of the process to disable ASLR. I don't think that's what Claude. I don't think what Claude said exists. The given one should work. Oh man, I don't think I can do this though. In my case, it's more complicated. Hmm. What about this thing? Is this thing real or not? Yeah. This seems to have been a lie. Snow leopard will be obsolete soon. The reliable workaround is to set ILD no pi. Okay, so this is like this maybe used to be true a long time ago. None of these things that I'm seeing here seem to consider this an actual thing. Although you're suggesting something different. Target.disable ASLR, not Apple security lib randomization.disable, huh? I don't know. I could try. Oh, it's an LDB setting. Oh, you know what the problem means? It still won't work because there's a ton of multiprocessing going on. So I cannot invoke the test directly because the test needs to be driven by the build system. And I think that if I'm gonna try now, but if I invoke the build system, then this I suspect this is not gonna work on the other things. So this would be then Zig2 build test fuzz. The specified core option doesn't exist. Setting stable disable target disable ASLR. So no, it seems that the setting doesn't exist. Can you print the address of MH execute header? Yes. Okay, let's do a run. This is it for this run. And PCS is, you know what? Maybe I shouldn't even do the subtraction at this point. Let's just leave it naked. Let's print it as a pointer. No subtraction. Okay. So here's what I want to do next. let me rerun object dump on this bad boy. Do-do-do. um, Sankov counters, Sankov PCS1. This still says data. Oh, it's the type. Okay, but now they're not close as they were before anymore. Now they're a bit separated because I'm guessing this is all the const stuff. Is there no way of seeing this information like without doing the whole O-tool stuff? I guess. Data const. Okay. Christopher IT, any idea when 014 will be available on Brew? Well, I can tell you that first it needs to be actually released from Zig. And then after a few days, it will probably get on Brew. Maybe not even a few days, but it might be quicker than that. But it will. Long story short, we haven't released it yet. So the original release date that was supposed to be mid-February has shifted to I think it's the 3rd of March. So in any case, basically it shifted forward like a couple of weeks. So you need to wait a little bit more for the release, but it's still coming. The upside is that like the reason why the release is shifting is because it seems that the custom backend for x86 Linux, x86 64 Linux is actually very close to be complete enough to be turned on by default. So it means that you will get very fast, well, pretty fast debug builds of things on Linux. So yeah, look forward to that. Okay, so my stuff here seems to make sense. This does not make sense. Yes, the address, okay, the address doesn't match the address on this because of this ASLR stuff that I can't turn off. My OS from scratch definitely did not have any any feature like that. So that's why I wasn't thinking about it because I was thinking about my experience writing my own OS from scratch. And yeah, I was mapping things one to one and not thinking about it much, huh? Okay, so the next question is why are we fucking up these things so much? Why are we fucking up these things so much? Maybe I'm wrong in placing the double underscore here, and I'm wrong in placing the double underscore in the other thing as well. Maybe this should be single underscore. I don't know if this really changes anything though. I think I might be just shifting things around for no reason. In any case, where else is this stuff decided? In internal object? No. So have segment start, section start, section end. Also, I did this change where I put underscores everywhere. Maybe that was wrong. Maybe that was wrong. Oh, here it's referenced. Oh, there we go. Okay, we might want to try and understand some of this logic because maybe this is where the math is wrong at some point. Yeah, I think so. To create a fake input sections text, comma, double underscore. Okay, so in these examples, this comment is using double underscores. So maybe this was not wrong. Although there's definitely one thing that I did that was bad. So in my fixing, I started adding underscores everywhere, and that was entirely done by me. And maybe I should start by fixing this. Maybe I should start by undoing my change to the underscore stuff, and then move from there. Really? No prefix matching in here anywhere? Oh, come on. Prefix? No prefix matching. Then object. Really just the object? No, I think I'm missing something. There was some other thing. Wait. Git log patch. What else did I change? Yeah, it prefix. Where is this stuff? Init synthetic sections. In macho. Oh, so this is in macho. Okay. So this other code that I changed is all in macho and then internal object. Then I added a print that we never hit. Okay, so those prints that we never hit, I need to understand what's going on here. Okay, let's keep on doing our stuff. So macho. To do check seg name is valid. I would expect this linking to fail after. This is my previous build when I was making some changes. Now I'm breaking more stuff now because that approach that I was using just to make things work, I think it's not the right one, and I need now to try and see what is the correct way of doing it. So I would expect this build to fail. It did not fail. Okay, so it just means that it has like a mess in here. No, no. Yeah, okay. So this has a mess. In any case, yeah. Now I'm breaking more stuff. Stubs got in fuzzer. In fuzzer, it is correct to want double thingies then. Did I change this at all? Did I not change this? counter start, PC counters end, start end. Okay. Then Macho has, I think, 2 places where this happens, right? Yeah, so I think I did one. There we go, the other one. Segment start, segment end. Okay. So now we should start getting failures when trying to build the executable, because the linker, like when it was like this, the linker was failing to match those symbols and they would remain unresolved and like things would go wrong. Now, the problem was related to it was related to those print lines that we don't see. So in Zig object, there's update nav code and delete export that have 2 prints of us prepending an underscore. So long story short, here's what the original problem was. The linker would fail to resolve symbols because some symbol names would like basically gain a underscore prefix in this code. And it seems that this seems to be too early. But I had debug prints to check if we were invoking these functions, and it seems that we're not even invoking them. Although Andrew was saying that in his opinion, there's like a choke point. You have to pass through these functions, and this clearly is a piece of code that adds an underscore prefix, but I could never see these prints show up. So I don't know. What I'm thinking is to change those prints to panics, so that if we hit them, there is like no way we don't recognize that we're hitting them. I am mildly concerned that something might be eating our output. Let's see though. In any case, run it. Not that it is wrong. Let's remove cache. Build again. Yeah, this is one location. There we go. Now we have this problem because this undefined symbol. Okay, so basically what's happening is that our fuzzer code inside fuzzer init is trying to find these symbols. But an underscore gets added to them. Yeah, I think I understand what the problem is. So what's happening is that I think what was happening is that every time we don't add the extra underscore. When referencing macOS symbols, there's an extra underscore every single freaking time that goes everywhere. And so we don't add that one because it gets added for us. The problem is that in this specific case, that underscore messes up completely the detection of these things. And so we need to understand, where is this happening? Where are we adding this extra underscore? This looks like and the fact is that these guys really do look like good candidates. This is one. And this is the other. But then why are we not hitting this? Panic. This is now panic. Let's see if we hit the panic. And once we understand who's adding the extra underscore, then we can do so conditionally and say, yeah, don't add the underscore if there's like a dollar sign in the name, because it's one of those weirdo symbols. Andrew was very confident that we should be hitting this line here. Come on, give me a panic. We don't hit that panic. Okay, let me remove cache. So normally you don't need to clear the Zig cache for correctness, but the fact is that I'm changing the compiler itself, and the compiler itself is a different version, but it doesn't have like a different tag. So like they're like different. If you update as a normal user Zig, then Zig will know that it's a different version of the compiler and will basically hash it correctly for caching purposes. But in my case, I'm not generating like a unofficial release of the compiler. I'm just modifying it kind of in place. Okay, so that panic is not hit. So we know for sure that that panic is not being hit. If we don't hit this one either, then I swear to God, I have no idea what's going on. Update nav code, or who calls update nav code? Update func. I should have deleted the cache. I think I might undo my undo. I think I might undo my undo because where are we now? I'm still trying to understand another thing that is specific to the Z compiler. But I'm not convinced anymore that the change is desirable. Out of curiosity, who's doing this on a global scale? Translate C is preparing stuff. Muscle. Link elf, we don't care. Link cough, we don't care. Plan 9. Macho zig object, blah, blah, blah. Add objective C export. By the but I don't think this is it. Cogent C LVM underscore F2 underscore F3 SEMA arrow, we don't care. Tests, tools. Hello Bytes Watcher. Who the heck is adding that underscore? Like there's literally no other place in the compiler where this printing is happening. I'm guarding this with a panic. So if we pass through here, we should panic. It's also kind of weird that we're not passing through here, to be honest. Why are those dead paths? The Macho Bible. Ooh. Probably filled to the brim with bodybuilding instructions, huh? Cool, thank you. This is an interesting resource. I didn't know that it existed, and it might be worth scrolling through it and like reading it, just to get an idea of what the ecosystem is. Although, yeah, I think that to some degree, to a good degree. Thank you, by the way. This is a very good resource. I'll keep it in mind. I'm gonna put it here. I think to a good degree, what I'm battling with is Zig specific stuff. Yeah, like this thing about the underscore is driving me nuts. It is really driving me nuts. Like this is crazy because the only guys that like the only one that do this are like here it's happening, but somehow this is not being called ever. I think I think maybe I get this. Maybe this is because this is that code because it's incremental stuff. Hey, Giacomo. Thank you for the raid. Hello, everybody. Welcome to the stream. Fair warning, this is a bit of a peculiar stream. I am trying to debug linker issues with the Z compiler, trying to make our own native fuzz testing support work on macOS. And we have a custom linker. And I don't know how linkers work. I mean, I know, the big picture idea behind linkers. But once you get now down to the nitty gritty, there's a lot of stuff, especially on macOS, kind of a cursed platform. And so, yeah, that's what I'm working on. So here's my plan. I think I'm gonna undo the changes that I just made. So the changes that I undid, I'm gonna redo, and then I think I want to continue investigating. So I'm gonna undo this underscore stuff. I want to continue investigating the math issues. I want to continue investigate the Z math issues. So let's put back the underscores. And then basically what I want to do is, okay, now that we fix the matching part for these synthetic symbols, then let's look at the logic and let's see if the logic somehow can tell us why we're doing something, why we are putting like wrong numbers, which is going to be a kind of worm in on itself, I think. Is this it? Did I fix everything? I guess I can do git diff. Yeah, thank you for the raid. Have a good dinner, Giacomo. Right, so I added the second underscore, which was actually correct. We are grabbing the MH stuff. We have a bunch of disabled instrumentation here and there. This is borked. This is missing an underscore. Okay. Like data const is good, but it's missing underscores. So let's go into LLVM. Data const, Sankov PCS1. What was the other one? Was there only one or there were two? And also counters. Although, no, counters was fine, right? It was just, oh no, it does have a single underscore. Wait, where is this? Here. Okay. Okay, let's build the compiler in this state. So, unless I messed up something, what we should see is that now we are able to build the fuzzing executable. The fuzzer should not be able to find any crash because it's not working correctly. We should still see that we are generating wrong addresses for these guys. And then we need to see what happens after that. Another thing that we should do maybe is try to follow the lifetime of this thing, because this is the variable that represents this section. So like somebody somewhere somehow needs to stuff contents in this guy. How that happens, I don't know, but it should happen, right? So for example, if fuzzing is enabled in update func, maybe we should also test if we are entering this function. Although we know that for sure we are, because changing this value causes different outputs to like, it changes how the thing behaves. So we know that we're passing through these guys. I think it's also interesting that here we're doing counters, and then if fg.fuzz, here we're doing PCS1. Also, here's another thing that I'm thinking. In the fuzzer, maybe we should add some more printing. So for example, we are printing the base address, we are printing PCS, we're printing the LAN. Let's print also counters. Hey, Blurry Cat. What are we doing today? I'm trying to make progress with getting Zig native fuzzing to work on macOS. It's gonna be kind of a obscure stream. Don't worry, no worries. It's a bit of an obscure stream because people usually don't know how linkers work. Spoilers. I myself don't know how linkers work, but I'm trying to learn a little bit. I'm trying to mess with the code and trying to, bit by bit, get some understanding of how things work. And I do get some of it because I'm able to make some changes and like obtain things. But yeah, it's a bit obscure. So yeah, before I build the fuzzing stuff, let me add some more pre-debugging, right? So we want PC counters. Let's take a look at PC counters. Could you show again how you obtain the errors of PCS1? Yes, I can show you. Let me just run this stuff once and see if I missed anything big and just take a look at how it behaves. Okay, so it builds, starts fuzzing, but it makes no progress. We look at the logs and we see that base is this number, PCS is this, length 0, counters also is the same. So these addresses are all, we're basically back to where we were before. Okay. How you obtain the address of PCS1? Yes. So how do I obtain that? I obtain that. As I understand, the way this works is this. Let's not start from here. Let's start from LVM code gen. So the way I understand this is that this is code that generates LVM bit code. And the way it works is that we're like literally telling LVM to create this variable and then set linkage, set mutability, set alignment, set section, blah, blah, blah. So we're saying this variable lives in this section. And here we're specifying the section. Then what I know is that if a section name happens to be a valid C identifier, so normally section names have a dot in them, I believe. But if a section name does not have a dot, for example, or in any case, it is a valid C identifier, then the linker, like linkers normally generate also __ start _ whatever this thing is. So suncov PCS1, and then they generate also end or stop. Stupidity question: what do two leading underscores in var name the node? Yeah, it's a string. It's like it's linker stuff. Linker symbols tend to have this stuff. You should put PCS1 back in data, not data const. Why? It should not be modified at runtime. I don't think this is the problem. I mean, I could do it, but I'm not convinced that there's any advantage to it. No, it should not be modified. Counters should be modified. I can tell you also what this stuff is. I don't remember if you were present when I was explaining it earlier, but I can explain to you what these things are supposed to do. So because I know at least that much. So I know that the linker is supposed to generate these symbols here, where start points at where this section begins, and end points at where this section ends. And I've used this trick a bunch of times in elsewhere. Like I was doing like an OS from scratch book, and we were placing stuff in dedicated sections and using start and end symbols to obtain basically a slice to know the length of a given buffer of data. So apparently the way this works is that, or at least the way we're making it work currently, is that we are creating, these are what's called, they're like synthetic symbols. So the __ start and the __ end stuff, they don't become real symbols that exist, like that are like, what to call them, like exported by the object file. Like they are global symbols. In any case, they don't show up there at all. They are symbols that get resolved immediately by the linker, like right away. So the way that works as I can see, as far as I know, is that when you want to refer to those synthetic symbols in your external definitions, you use section dollar start and you use section dollar end, and then you pass the rest of the thing. Another interesting thing is that here we are using a dollar sign as a separator and not a comma, even though here we are using a comma. But the reason this, unless I'm wrong, this seems to make sense, is because in here in this code, you can see that we're doing the section start dollar sign stuff. And then later on in Macho, we are doing, I think we're doing more, right? We're doing, when something is section, we expect section, then start, and then we expect to find another dollar sign afterwards that then gets used to split the segment name from the section name, right? Because sep is the index of an extra dollar sign after these guys, and that gets used as a separator to split. And this gives us this segment name and section name. And so we do get section by name, and then we do add section name. Also, what if this is not null? Now I'm kind of curious. What if get section by name? Oh no, wait, this is saying if that section doesn't exist yet. Right. This is just for the section. Okay. So this is how this mambo jumbo works, as far as I know, within Zig. Now, why should PCS1 be data const and not data? For this reason, fuzzing works in this way. There is PCS and what is it? CNTS, TRS, I think. Well, in any case, this is counters and this is program counters. So program counters is literally an array of U64s where every entry is the address of a of a point of interest. Maybe it is the ASLR thing. No, because we are definitely grabbing wrong data. Okay. In any case, so this is a list of addresses in the text section in your machine code. They correspond to if branches. They correspond to greater than, lower than, equal comparisons. They correspond to every time there's a comparison. So, and this is what imp sees. For each entry in here, code coverage, exactly. For each entry in here, there's a single byte in counters. So this guy, PCS, is 8 times counters. For each of these guys, there's a single byte, and the single byte is used as a counter, so it can go from 0 to 256, 255, whatever. And the idea is that as the program proceeds, as the program is executed, every time one of these guys is hit, the corresponding bucket is increased by 1. And so that way, basically, at the end of an execution, this thing is kind of like a somewhat unique trace of where your program execution went, more or less. Because fuzzing is based on code coverage, and fuzzing is not based on perfect information. Fuzzing is based on since it has to keep track of a very big state space, it just contains a little bit of this stuff. Exactly, that's kind of the idea. So because of this reason, then counters has to be mutable because you need to reset and increment these bad boys. But then this guy never changes. This guy is defined basically when compiling, and it stays like this. They get generated automatically in link time. They get generated by the front end. So the front end code in, I think it's semantic analysis, collects these things. Well, I guess that's where it starts, and then I'm guessing the linker finalizes what the address should be, I guess. But in any case, yes, it's done by the compiler at link time. There is no, like, it doesn't happen at runtime. Yeah. At runtime, you expect to find the values already in there. Okay, so let's see. I think this stuff doesn't seem interesting because this linker code is just like doing. To me, it seems like that it's doing like boring bookkeeping about these things. It's not really worrying itself about the contents, or at least this part of the linker. Maybe there's other parts of the linker where there's more direct interest in these things, and in that case, we'll see. For example, there's no mention of Faz, Sankov. No mention of Sankov in Zig object, so maybe this guy doesn't care. Let's take a look at what's happening here. So with LLVM, we create a variable that is supposed to live inside Sankov PCS1. Set initializer. This guy ends up in funcgen. Also in funcgen we have both fuzz. Where is fuzz? Function has fuzz, and if function fuzz is present, then what happens here? Array LVM type f dot. Okay, here's the side effect. F dot counters variable. Hey Matt, hello. Thank you for the resub. Good morning. So array LVM type, array type of length PCS items.len. Wait a second. F.PCS? F.PCS? Excuse me? Excusez-moi? .items.len. So this guy, at this point, we're supposed to know what this goddamn length is supposed to be, right? So let's go up. This is fuzz. PCS is default initialized. So then maybe it does not know. Maybe this stuff is initialized empty, and then it's, yeah, I guess it's gonna get pumped afterwards. Builder.constant. Okay. So no, we do not know then. We have the counters variable. Pointer const global ptr dot type. I'm kind of curious. Why are we splitting this into two sides? Oh, wait a second. I know I get it now. It's because the call to gen body. So here we initialize everything to like these things. Like this thing is empty. Then we call gen body. Gen body is supposed to fill that thing up, and then after that, we have its counters variable that gets like initialized based on what it finds in PCS items. So if here we put a print. And let's print the length of this thing. And by the way, in reality, you know what? In reality, we know that this is not empty because we know that the size of this thing is meaningful. We know that this thing has these things. We know that they have a size. We could probably even modify this size by adding interesting stuff in here. I think if we build it and then we object dump it, we should see that the size changes. Uh, 170C, 170F. Yeah. It still counts as, right? Yeah. Yeah, so we can change it slightly. Actually, wait, what is this? Is this less? $878. This is still kind of borked, but in any case, 878. And this guy is, or what is it? B860. In any case, so yeah, we can change the size of this thing by changing the code. So yeah, we know that this is not interesting. We know that this happened here. This is, so gen body actually did its work. Let's see, coverage point, if self as, there we go, point of interest, index is the length, base pointer, blah, blah, blah. I guess it's deciding if this thing is interesting or not. If it is, it's making an int value, counter, whip load, int value, blah, 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 whip store. There we go. Faz PCS append. So we are definitely appending to program counters whenever. So this is working. CodeGen is working. Now, so then we are definitely fucking up in the linker. Okay, where did I start? Right, I started here. Hello, Stu. I started here. Update stuff. Okay, so this is still okay. So I'll assume the code gen is all fine. I guess I wish I knew exactly where the linker stuff started. Like if I could get some kind of entry point and kind of follow the data around, that would be nice. No Sankov. We do have start stuff. So let's see. Init synthetic sections. This seems interesting. Init output sections. Oh, right. I know what these guys are called. Okay, so this is our main function. Okay, our like flush module is our main linker function. So it scans for relocations, init output sections, init synthetic sections, sort sections, add atoms to sections, calculate section sizes, generate unwind info, init segments, allocate synthetic symbols. Write sections and update linked IT sizes, link edit sizes, write sections to file, allocate link edit segment, write link edit sections to file, and then code signature. So our problem is in here, I think. There's probably something going wrong in here. Init synthetic sections, allocate synthetic symbols. So let's see what we got here. Data const got data text stub, blah, 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 thread pointers, unwind info, get internal object. This is the underscore stuff. Segments append, command size, segment name. So this should not be it. This should still be fine because in the end, we do get the right stuff in the generated executable. So this should be fine. The problem is we are resolving the synthetic symbol externs wrongly. I think that is where things are going wrong. But I will continue reading a little bit more. Any segments, allocate sections, allocate synthetic symbols. Oh shit. Oh shit. Oh shit. I see something that might be a problem. Huh. Uh-huh. Uh-huh. Oops. Oh my god. And then so what was happening is that we were failing this check, I guess. And so we were never giving it the correct value. But wait, although to be fair, wait a second. No, we weren't using segment. We were using section. So I don't think this is all of it. I think this is a fix that we need to have. Oh, although I did have it here, did I not? Oh yeah. Oh shit. You know what? That might be it. That might be it. I think we might have fixed this. I don't want to be too optimistic, but I think we might have fixed this. If we have fixed this, I mean that section, like I don't know for sure what the meaning of this is, but it does really seem like, yeah, look, this is actually writing down the address. Hey, okay, let me show you what it was before. Okay, this is what it was before this code. This part here we don't use in this case, so it's not interesting. But like for example, check this out. This is what it was before. So what was happening, I think, is that we were wrongly. This was out of sync with this because it was basically using the wrong length, and so I think that we were splitting things in the wrong way, which caused us to fail in finding the section by name. I think honestly, I think that if you get to this point, it's not an if. Like if you get to this point, this has to succeed. Like, what the heck? I think. In any case, this was not succeeding, and then we were not writing anything in there, and I think we were just defaulting to good old 0. Now, let's see if I'm being too optimistic. Clean cache. So success looks like that the fuzzing process crashes right away because it finds crashing the executable, and that also crashes the fuzzer. That's how it works currently. I don't get how it's linked to getting the wrong address. It's linked to basically because we were never setting. So that synthetic symbol was never resolved to the actual address because this code, like we're never entering. We should have. So the fact that this is structured as an if is very sus to me. I'm not sure that this should be the case. I'm thinking that this should be an assertion. But what was happening is that we were never setting this, right? So it was, yeah, not the content. The content is fine. We were never wiring in, though, that external variable to the right number, to the right address. So with this fix, we failed successfully. On Linux, it's much faster than this. But yeah, it worked. So it was basically me all along half-assing the implementation. We have it working. And by the way, you can now see the power of... You can see now the power of fuzzing. It's insane. So imagine this, right? You have a program that only crashes if a password is found, basically. But that's the reality of it, right? When you have a normal program, the reality is that it's not going to be immediately trivial inputs that make it crash, right? The fuzzer has to try a little bit harder. And so the reality is that the actual inputs that make it crash for real, like the interesting, useful crashes found by the fuzzer, require the fuzzer to basically kind of find a password. And with code coverage guided fuzzing, you can have it. And like this is extremely synthetic, but it showcases the core principle of the power of code coverage guided fuzzing. You give it a password and it finds it, and it finds it fast. Like, let me take a banana. You know what? We'll run it twice. Well, or in any case, you can see it here, right? So this is running, and this is kind of slow, by the way. I think that on Linux, it really doesn't take this long. Okay, now this is taking very much longer than I expected. What's going on? Oh, look at it. Now it works. That is so cool. So why are we not being good at fuzzing now? Now we're bad at fuzzing. Why? Let me remove cache/f. Okay, now the fuzzing is starting from scratch. There we go. I think there might be something wrong with how... Oh, you know what? There might be something wrong in how we resume, though. In any case, yeah, this worked. This is how long it took you to find the password. Do we have timings somewhere? No, we don't. Well, I'll remove the corpus cache. Try again from scratch. Actually, let's remove the bug-rt stuff. So let's just run fuzz. Yeah, it's also random. So yeah, it's not supposed to always have the same performance characteristics. Oh, there we go. You know why it was low? It's because I was building the fuzzer in debug mode. Now that it's not in debug mode, it's actually doing what I expected it to do. So be actually fast. So if I remove the cache, like you can see, like boom, that's how long it takes to find the password. It is so cool. Truth be told, so just to manage expectations so that you don't get the wrong idea, Zig currently has a custom, like the fuzzer has a strategy that it needs to implement to decide how to keep exploring. Some of it is randomized, some of it is about making good use of code coverage information. There are different algorithms, they all work better or perform better or worse depending on, let's say the specifics of your program. The one that Zig implements is not as sophisticated as the one in AFL++ so far. It's a POC one then remade. So it's not necessarily bad, because oftentimes you do discover that sometimes these solutions become like overcomplicated because people try things out and like they collect like special behavior that really doesn't do much, and then so it's not like a more complex algorithm is necessarily better. But that said, chances are that the current implementation is not going to be as strong as the one in AFL++. So if you try to do the "can you find me" thing with AFL++, it takes longer. The fact that it takes longer in AFL++ doesn't mean that our implementation is better. And so maybe the best possible fuzzer in Zig should not be able to find a password this easily, because it should be optimized for more real use cases. That said, we currently find the password pretty much instantly, much faster than AFL++, which I think is pretty cool. So now I have a patch set that I can, well, I was about to say that I can commit. Not true. I can't commit this patch set because I have a bunch of hard-coded choices that are like hard-coded for macOS. Yeah, I basically need to add switches so that we keep doing the normal thing for Linux and then we do the weirdo thing only for macOS. But that's it. I don't know what the fuzzer algorithm is, but I'm pretty sure it does not find the password. What it finds is pass that validates the password. Well, more specifically, the way this works is this. When you're compiling with the fuzz flag enabled, what Zig does to help fuzzing is turn all string comparisons into an extremely unoptimized version of them. So in a normal program, string comparison will tend to be vectorized. And so it's hard for the fuzzer to to recognize a partial success. Like, let's say that this gets vectorized into just one big SSE instruction, right? I'm simplifying a little bit, but let's say that this becomes just one comparison using SSE. At that point, the fuzzer will only see that basically you loop once in a for loop, and then it cannot know that it actually discovered a new state because it got right, the first 3 letters or the first 4 or 5 letters. But if string comparison is lowered in machine code as a literal, as a for loop that does byte by byte comparison, then every time a new byte gets is right, then the fuzzer will see that it's one more loop in the for loop. And so that will become a new state of the program. And so it will allow basically the fuzzer at this point to kind of find passwords. That's the key point. So basically, the compiler is really lending a hand. Like, it's making the fuzzer's life much easier by implementing string comparisons as a byte by byte comparison always. So this is what I mean by finding passwords. And actually, this is useful, for example, in parsers. Like my HTML parser, I could see the fuzzer know how to explore my tokenizer, because while doing token string comparison, it could see that it was doing like you do script, and then script, if you get script right, then you go into the sub part of the tokenizer that tokenizes script tags, and greater than signs, move state somewhere else. So it's actually really practically useful to have this feature implemented, because it makes, in my opinion, or at least in my limited, but in my experience, as limited as it might be, in my experience, it makes the fuzzer kind of not even need a corpus or a dictionary, because it's I guess slower than having maybe a dictionary, but then it's just able on its own to navigate tokenizer string comparison. So it's really cool. Maybe that's why LM 19 stops after 4 characters. That it could be the pre-loop until the pointer is aligned. Maybe. That son of a bitch, huh? That could be it, actually. Yeah. I didn't know exactly what it was, but it was very consistent, and it did seem that it was something of this kind. Because he was very efficient at finding the first 4 letters, and then he would just give up every single time. Anyway, so we got this working. Now I need to make this patch digestible and convince Andrew, hey, Grey Hatter, what did you miss? I got fuzzing, native Zig fuzzing working on macOS. That's what happened. It's not yet ready to be PR'd. I need to clean stuff up, but we got fuzzing. It's not all working. There's a web interface. Like, this fuzzer should have also web interface. There's no way it found, can you find me faster than banana? I think it never found banana. The banana one, like, I did have a second banana crash, but I don't think it was ever found. I think it found, can you find me both times. I think every single time it only found can you find me, never banana. Also, I was running initially with a debug build of the fuzzer, and then after a while I remembered that that's what I was doing, and so I started running the fuzzer without a debug build of the fuzzer, and it made it more efficient in theory. But there's still a bug, because if I run it with a pre-existing corpus, actually, no, you know what? This is not a bug. This is not a bug, maybe. Maybe this is just the fuzzer already knowing that the input is a crash, and then it's just now searching for more. Let me see if actually this is true. So I'm going to do, can you find me? And banana. And by the way, and then we can go check out what the outputs are, because they go, there's a, somewhere in the cache, this information is stored. And so we can go find it. So I did banana, and I'm going to do another thing. I'm going to do embedded boy. So let's build it. Actually, let me first delete the cache corpus stuff. I thought you were just showing it off. Well, now I am. We crashed. So we immediately crashed and found a crash. Now, where is this thing? I think this is it. We don't have one. I think now we will find one, maybe. Now it's trying stuff. But it doesn't seem to be making any progress. It seems very confused. You know what? Here's what I can do to show you maybe something interesting. Okay, let me do this. I'm going to start observing 0, which is the first one. But as you can see, this one has already, like, this is done. It knows it. So here's what I'm going to do. I'm going to remove this stuff. I'm going to start from, wait, I'm going to start, no, remove this one. I'm going to start from scratch, and I'm going to do debug RT. So now we are running a slower version. It's going to take longer for it to find it. Oh man, but it's still too fast. God damn it. Let me try again. I just want to show you the progress. Can you see? Okay, you can see that it's so fucking fast at finding it. It's so fast. We're like barely able to see. Now, why does it poop itself when there's already stuff under F, which stands for corpus, I think. I'm actually not sure. I guess it stands for fuzzing. So I guess another thing that I need to understand is why it gets stuck there. Because 0 now is done. 1 looks like this. Do we have 2? We don't have 2. So 1 now is just very confused. Because it panics. I think so too. I think I think you have a good read, Grey Hatter. Yeah, it might be a panic that gets because it panics. No, but even if that was the case, then I think this input would be recognized as a good sum the output of the three and then panic. So this would work, yes, but I suspect that this is something else. One thing that we were experiencing is that basically instrumentation, that some of the startup code ends up being instrumented, even if you don't want it to be instrumented. And that had caused some UB in the code somewhere. Maybe this is what we are experiencing here. I don't know. But yeah, just for the purpose of showcasing stuff, maybe we can do your suggestion. I think it's interesting. Although I can't do all of them at the same time now that I think about it, because obviously, I guess I can do either. I guess I can do a longer password. Yeah, but the equals are never going to be true at the same time. They're like mutually exclusive. No. Yeah, but how can a string be equal to three different strings at the same time? No worries. But it's pretty cool seeing it figure out the password, huh? Yeah, it's awesome. Um, try a condition that doesn't crash and a second condition that does. Yeah. Oh, sorry. I don't know how to program Zig anymore. It goes straight for embedded, boy. Is this ring equal to what? Look. It goes straight for the other one. It doesn't really care much about this, huh? I'm just complicating this branch just to see how I can trick the fuzzer. Oh, also, you know what? This might have something to do with the order in which I'm placing this stuff here in input. I'm not sure, but um, maybe. Really? Equal, yeah. Equal for the fuzzer guarantees, like it ensures that string comparison happens byte by byte so that the fuzzer can observe a single byte change, uh, making progress basically. But this still doesn't answer why we're not doing this. Where we're not. Okay, what if I take this out? Now I'm curious. Now watch me modify the wrong file or some other dumb stuff like that. No, it couldn't be because we were actually causing a change earlier. But I'm really curious why this is not behaving how I expected it to do. Okay, now it's trying Bananarama. There is some scoring system that must prioritize the other thing more over this one. Either that, or it just takes an instant to explore Bananarama. Maybe I can make this longer, but I think the other one is somehow getting prioritized every single time. Does the fuzzer use binary search and it comes across EB4B? No, the fuzzer cannot do that. The fuzzer doesn't know the fuzzer. Well, I think the fuzzer could understand that it is some of its input that is being used in a comparison, but our current implementation doesn't do that. Our current implementation, and I don't know other implementations, but as I understand, here's the problem. Like even if you can do this, the problem is that this technique becomes not useful very quickly because at some point you have comparisons. Like you have your input, right? You have the B and the A and the N, etc. But then at some point, this will use to generate other data that will go into comparisons. So once you have derived data, then it doesn't work anymore because you don't know how to do, like you don't even know how to do binary search in a general sense. So the way this works is that it's literally just what is it? Mutate and run one. It literally applies a mutation to the input, and then it runs it. It runs the input, and then it looks at the scene PC counters, the code coverage information, and it uses that to input is already committed to the file system. We just need to open a new file for the next input. So, and basically, it keeps the only mutation. So let me put it this way: the only mutations that are implemented for now are based like this. They are randomized, and they are remove byte, modify byte, add byte. That's how the parser makes progress. Yes, it can see this, but in banana you don't even know which B or N. So like you can do it. I'm like, I guess if you want, you can do this stuff. And that's literally what you have. You have all these functions. You have sanitizer, cov trace, compare this, compare that. So you have this info at your disposal. The problem is that I think in the general case, it's not as easy to leverage it. So for example, a comparison byte by byte is it's I think this one in our case. So you could definitely see this. And then you could say, is arg1 potentially one of our input bytes? And so you could try to reason, wait, that's an A. Did we give an A to the input? Then this might be our A. And our A is being compared against a B. So maybe we should next loop, we should turn our A into a B. You can do that, but you don't even know what the index is. here locally. So you would have to have some more tracking information. Maybe it's a genius idea. Maybe this is how you implemented the next gen fuzzer. I don't know, but you've seen that with just this silly approach, well, quote unquote silly, but like with just this basic stuff, this is already powerful enough to express all the transformations that you need. And it's more that you try changing byte n and you see a compare argument change at the same time. All the deprecated fuzzers already do that. Yeah, look, they all do that. And where did they end up? And where did they ended up? In the deprecated bin. So who knows? I don't know if I would call this the naive approach necessarily. I guess you have guess you have two problems in my mind. One is you need to have a expressive power when it comes to mutations that should allow you to output all kinds of inputs for the fuzzing function, right? And this is bare bones, but this is enough. Mutating bytes, adding bytes, removing bytes, these are enough to obtain that level of expressiveness. Then, so you have that. And then the second problem is, how do you make progress? And so you could argue that having that logic helps you make progress faster, right? It's not a problem of expressiveness. This guy will be able to get you every place that this logic will be able to get you. So it's not a matter of expressive power. It is a matter of efficiency. You could argue that in this way you get there faster, maybe. But it's also true that, you can also, as there's an advantage in having your logic be that simple, because by having that simple logic, then you can just loop faster. Like at the end of the day, fuzzing really benefits a lot from just being able to pump out a fuck ton of iterations in a short amount of time. Obviously, I guess there might be a strategy that beats this approach in terms of speed. So who knows? Maybe it's a good strategy to have. I have no idea. I guess my point is, this is not limited. This can produce everything that you want, and then there is already logic for how to make progress in the program. And lastly, I think there's also one last question, which is, if you look at the other fuzzing stuff, it tends to be somewhat synthetic in the sense that, for example, your execution trace, like the code coverage information of which branches you hit in one run, is not even given to you with full precision. Like there's already some loss of precision when you receive this information, because apparently, I'm guessing, people concluded that having perfect information for a given run is not all that useful, because at the end of the day, every interesting program that is worth fuzzing will have a state space that is going to be too big. And so in reality, you have to be lossy in the way you record information about your path through the state that you have already explored of the program, because otherwise you would have like an explosion of memory consumption. So I guess that basically this being basic and fast to execute, and then having logic that prioritizing exploring certain, like a concept of novelty when exploring state space, I think this seems to be the two big things to hit. I guess. I don't know, honestly. It's not like I've ever written a fuzzer. This is just based on me looking at fuzzers run. But it's cool. It's cool. I think it's going to be cool to take a look at the Zig implementation, because it's obviously going to be less cursed than whatever C++ implementation is in AFL++ and company. And so it's going to be cool maybe to try and tweak it and like mess with it and see what happens. So like if you want to implement this strategy, you can, right? You totally have the opportunity to do so. So it would be cool. And now it works on macOS. Okay, so with this, I think I'm gonna end the stream because it's getting near time. I know that it's not It wasn't a super long stream. I apologize. But hey, I did do the work that I set out to do. So today it's a success. The refactoring work to turn this from macOS only specific stuff to stuff that also works on other platforms. I don't know. It's going to be just boring and annoying. By the way, GXKZ, thank you for your support while I was looking at this stuff. Sorry, I didn't see your question. Is it fuzzing at bitcode level or bytecode? I'm not sure how to answer your question. It's fuzzing. Well, it's not fuzzing the LLVM stuff. Like, it's not interpreting the LLVM stuff. So it's just fuzzing the native final compile executable. Bytecode would be assembly, so R may be on your laptop. Okay, so yeah, the machine code. Yes, sorry, I'm used to think of bytecode as virtual machine code. In any case, yeah, that's what's happening. Like the fuzzer is literally invoking, it's literally running functions, the test functions, like literally calling them. And when the fuzzer calls those functions, then they in turn, as they execute, they call these functions here and they mutate. So they call these functions here and then they mutate the 8-bit buckets that we were talking about earlier. And so basically when the execution concludes, assuming that you didn't find a crash, because that would be a success. So when you don't find a crash, then at the end of the execution, you will have all these things being called, and then you will have all the buckets set to different numbers that then you can hash or do whatever you want with. And then you cook up a new input and call the fuzzed function again. So it's very native, which is good because, one thing that I understand is that really execution speed is absolutely your first and foremost thing that you want to think about. For example, you do not want to fuzz debug executables. You want to fuzz release executables, release executables that still have what's it called? God damn it. Release executables that still have safety checks in them. So you want the safety checks, and you do want some inefficiency. So you want string comparisons to be inefficient, but then you kind of want everything else to be efficient instead. And so release safe is the actual correct release mode to test. So they get extra speed. Okay, this is it for me. So thank you all for hanging out. Let me see if I can find somebody to raid. By the way, thank you people on YouTube. I apologize that I don't read your comments too often. I do read them, just not too often. Tiger Beetle? Is Tiger Beetle live? Oh yeah, Tiger Beetle. Oh, is MatCloud presenting the pull request review entirely without GitHub? Let's go. Okay, this is going to be an interesting thing. I do recommend you check it out and ask him to give you some context if you join. There are like tweets and links, so maybe he's not going to be willing to re-explain everything. I don't know, maybe he will. But at the very least, try to get some an overview, because it's really cool stuff. It's basically doing reviews of PRs, but without using the GitHub interface. Instead, it's like it's a pure Git workflow, which is interesting. And also go say hi for me to Alex.